Yeah, switch papers, please, for your quiz. Question number 1 is 25 milliliters or, yeah, that's the question. 25 milliliters of an HCl solution, that's hydrochloric acid, is titrated to the end point with 17.25 milliliters of a 0.100 molar sodium hydroxide solution. What is the molar concentration of the acid? It's not going to be important in this question, but in the next one, it'll be important to know that this is a strong acid. Yes? Yeah? You bring it up here, I'll grade it. Yep.
I have a question.
Yep.
Do you require us to use the method that you taught us, like the workshop and test, like that long line stuff?
Yeah.
Yeah.
As opposed to what? As opposed to what other method?
Oh, I'm saying like when I told my sister, she said she didn't know how to do that, but like she did this in the other method that was like 10 times shorter. She got the same answer. So
You have to show me all your work. So if her method doesn't show all the work, then no, you can't use it. Okay? You want me to grade your paper too?
no, I didn't use it. I used
Okay.
it. I'm just saying.
Here's the reason I have you put all that down is because I want you to show me every step. I want you to understand the big picture, not just know how to plug and chug stuff. Okay? You with me? All right. Because if you know how to do if you understand all the steps, you can apply it to other things. Okay? If you only know how to plug and chug, you can't apply it to something else. So I'm trying to give you something you can use that applies outside of chemistry by understanding how conversions work. Okay? You with me? All right. So I'm trying to keep it, a lot of times nobody here is asking much, but I sometimes get classes where students ask me, how am I ever going to use this? Well, conversions you're going to use. Or you're going to find your conversions are a lot easier and your life's a lot easier because you learn how all this stuff works. So that's why I'm asking you guys to do all the steps and show me all the steps to emphasize how these conversions work. Okay? All right. So, first thing you have to do is you always choose to put the starting amount of the species whose concentration you know on the top of a fraction. That's your starting amount, okay? That's how you identify it. It's the species whose concentration you know. The species is sodium hydroxide solution. We know the concentration of the sodium hydroxide solution, so we're going to start with that that amount, that volume, okay? Now this is for titration stoichiometry. You always start with the amount, in this case of milliliters is the amount, of the species whose concentration you know. Now the species whose concentration you know makes it the titrant. If you want to think about it in terms of you always start with a titrant, that's fine, if that helps you. Okay? Either way, you got to start. It comes out to be the same thing. You start with the volume of the titrant, or you start with the volume of the species whose concentration you know. Okay? All right. So you can either, in the next step, convert to liters using this ratio, or you can put the concentration next. Now, it's important to know that 0.100 molar NaOH is the same thing as 0.00 moles of NaOH over 1 liter of NaOH solution. Okay? So it's the same thing, but you need to break it apart into its component units of measurement. Component units of measurement in this case is moles and liters, and the component species is NaOH, and NaOH solution. So you have to have these steps here. You have to have an equality statement down here that justifies this conversion unit. Okay? Then you have to have a balanced equation and the atom inventory for me. Balanced equation, atom inventory shows it's balanced to have this molar ratio here. All right, now if you guys are just concentrating on checking off things and not listening to the explanation, you're not helping yourself much for tomorrow's test. Okay, you got to listen. I'll give you a chance to do all the grading. You got to understand the process for tomorrow. more important to understand the process for tomorrow than to grade this thing right this second. Okay? You with me? All right. Then you have to divide by the volume of your analyte solution. So when you get to moles of HCl, you want to divide by some volume of that solution. It's possible it can be given to you in liters, but in this case we're giving it to you in milliliters because that's how we most often measure it in a chemistry lab. So we're dividing by the volume and making sure that we get this volume into the correct units of measurement for molarity. And so we need moles over liters, not moles over milliliters. So we've got to convert milliliters to liters, and that's where we use this molar ratio. This conversion unit. And you've already written the equality statement down to here. You don't have to write it twice.
So if you were given the analyte solution in liters, all you have to do is put 1 liter on top of 1,000 liters a month.
You wouldn't have to even do that. If you had the analyte solution in liters to start with, you could just put it down here in liters, and you wouldn't even have to do this step, because all you're trying to do is get it into moles of your solute over liters of your solution. Okay? So really, you could, if you wanted to, convert this to liters before you start. You wouldn't have to do this step. Convert this into liters before you start. You wouldn't have to do this step. So if we wanted to shorten that, we could. But I've been teaching you guys to put it all in one long problem just to make sure everybody's doing it the same way. Okay, so you can help each other. All right? Now, the answer you get will be, in your calculator, will be 0.069. But just as in the problem previously today, you have to know you need 3 significant digits. Your calculator won't show you this last 0. You have to know, you have to be smarter than the calculator and know you need that last 0. Now, it's okay if you want to leave your answer in this form, but you can also write it in this form, because moles of solute over liters of solution is molarity, or molar concentration. So either one of these two answers is correct, and there's 3 points for the answer here. The whole problem, all the steps, all the cancellation, all the multiplication, all the equal signs, everything, and the arrow and there's no arrow here, all the operators like time signs and equal signs, all those together make up 49 points for this problem. Okay? You have to have the time signs and the equal signs in there to get all 49 points. Okay? Now I'm going to pause a minute and let you guys finish grading this. Okay? So if you'll just make sure you look up here at me so I know when you're done grading it, and then we'll go on to the next question.